And welcome to our ACCE Learning Network Hangout. This is Series 4, Episode 14. Wow, 14 for 2014. Hello, Amanda.
Hey, Roland.
And it's a place where we can connect the network of our PLN.
And as usual, if you're watching us live, you can post a question to the panel by going to todaysmeet.com/ACCELN on Twitter, or you can use, that is the Today's Meet site, or on Twitter, you can use the hashtag ACCELN.
Thank you. And I'm Roland Guesthausen, high school teacher, e-learning leader in Victoria, Australia. I'm also on the State Council of the ICTEV. And just an apology for last week. That was really horrid. I suddenly discovered that my network bandwidth had absolutely disappeared. And after making some furious phone calls and trying to join you guys, I noticed that what had happened was my ISP had suddenly reverted back to, oh gosh, ADSL1. It used to be slow enough, and we used to have dial-up modems, but I hadn't realized how slow ADSL1 is. I could barely just scratch my nose to be able to get in or to send some posts about what was going on. So that was really quite sad. And I did want to especially do a shout-out for Tony and Daryl, and they're the guys from the EdTech crew who joined us around Christmas time for our Christmas special. And last week they celebrated their 250th anniversary podcast. So
wow.
That's 2 EduTech poddies, and I reckon that's really well done, guys. Fantastic. And also a sad farewell. I had a dear friend who passed away this morning. She's known as VKC CFI, or we know her as Maggie. Wonderful IT teacher and educator, and she finally lost her battle with cancer of a family close by. She was the Melbourne Metropolitan lady teacher, mother, who was keeping the MIA astronauts connected and talking and collaborating with them. She's an amateur radio enthusiast, a hacker. I'm going to really miss her laugh and her passion and her really bubbly, giving, sharing nature. And I know I've been thinking about her today, and I'm not sure if we do dedicate shows, but I'd like to think of tonight as beaming out across the spatial galactic hemispheres that maybe Maggie might be listening in.
Absolutely, in her honor. Big hug for you too, Roland.
Thanks, Mag.
And I'm Amanda Ravlin, e-learning coordinator in Brisbane, proud QSite member and past board member on QSite. And we have some wonderful guests again with us this evening. Some regulars that we've seen before, some recurring ones, and some from other places in the world. And just to do a bit of a shout out, I'd like to say a big hi to Charlie and the others from System 45 if you're watching tonight. Okay, now to our guests. I'll ask you to introduce yourself left to right on my screen, which is actually alphabetically by first name. So Andrew, you're up first.
Okay.
Who's on first?
I'm just giving you a wave and saying hi.
Howdy. And where are you from, Andrew?
I'm in Tasmania at the moment.
Lovely. Must be a bit chilly there this evening.
You're absolutely right. It's freezing down the corridor of the house.
I'm sure it is. Big woolen jacket and scarf kind of weather.
Yeah.
And on the other side of the globe in summer, we have Christopher.
Hello. I'm standing outside my house, just dropping in, using my mobile phone, and I thought it'd be fun, and I pressed the button to accept Amanda's invitation, not quite sure what would happen. I'll just listen in for a time. I can't stay very long, but it's very nice to hear from all of you. I watched the video of your friend Roland, and I was impressed. I will mostly lurk and just stay here for a time. Bye.
That's okay. Lurking is most welcome, and thanks for showing us the sunshine. And Nikki, one of our special guests this evening.
Special guest. My name's Nikki Ringland. I am a co-founder at Grok Learning along with Tim, who you'll hear from in a second, no doubt. I'm also an outreach officer for the National Computer Science School. We run the NCSS Challenge, which will come up quite a lot tonight. I also run Girl Geek events down here in Sydney for high school girls mostly, and the National Computer Science Summer School. And in my spare time, I'm finishing off my PhD. I wish there were more spare time.
Don't we all?
That PhD, you just fit into the extra bits of your life.
Oh, I'm trying.
Awesome.
We're not the only ones, Amanda.
And in honour of the Tech Girls movement, tonight I am wearing my This Is What a Tech Girl Looks Like badge that I got at the QSite conference. Yay! So, Tim, would you like to introduce yourself to our viewers?
So I am like this subset of Nikki by the sound of it. So I'm Tim. I am another co-founder of Grok Learning. I also help run the challenge and help out in CSS, and I'm also trying to finish my PhD in my spare time.
Twins,
Yep.
must be. So this week, as Nikki mentioned, we're exploring computational thinking and also what the NCSS challenge has to offer students and teachers.
Tonight is really totally gonna grok.
So what do you mean? What is Grok?
So
Nikki.
I should probably jump in here. Grok is actually an old sci-fi term, so those of you familiar with Robert Heinlein's Stranger in a Strange Land will know it, but it's used a lot in the tech community now to mean really deeply and intuitively understand something, to understand it at a much deeper level than a normal surface vague understanding would do. So that's really what we are about in Grok Learning, about getting kids to have a really deep understanding of computational science, computational thinking, and IT.
So who came up with Grok Learning?
Well, it was a bit of a joint effort coming up with many names, but I'm the sci-fi nerd.
The name
Yes.
was the top choice. The name took many hours. Names are
Many
horrible.
pixels and hours. I just had this image of this dungeon below the first floor, next to the car park, where there were lots of computers, piles of pizza boxes, and lots of soda pop.
There were multiple texters and big pieces of paper where we wrote down everything, so a little bit less unhealthy.
But
True,
it
but it does sound like a
mango.
staff meeting. I can relate to that. And Andrew's nodding his head too. There must be like the meetings he has down in Tassie as well. But can I ask another trivia question, if it's all right? And I'll ask this one of anyone on the panel. Who remembers who came up with the phrase computational thinking? Now, don't go cheating and looking up
Quick
Wikipedia. I'm
Google.
watching your eyes there. Our listeners can, by the way. Let's just see if anybody pops it into today's meet room. Who actually came up with the term computational thinking?
I knew this once.
Oh, no, it was Papa.
Was it Papert?
And a point to Tasmania. Well done. Yes, it was Seymour Papert. Did you have a chance to meet up with Seymour Papert, Andrew?
No, but when he had his unfortunate accident in Thailand, I was talking to one of our members of staff, and he was pointing out that it was sad that Papert was in that accident, but did people realise the chancellor of the university in the area actually was killed in the same accident? So that puts things into perspective, doesn't it?
Wow. Well, it's a remarkable man for what he's given to education and learning. And I wasn't aware that that phrase had actually been something that had been coined by Papert. And for me, that's really appropriate because it gives some educational legs to an idea of thinking. And there are 4 dimensions I'm going to unpack. And Nikki and Tim, if you could help me out with this. The website I'm going to is, and you can look it up with google.com/edu/computational-thinking. But Nikki, what is decomposition, pattern recognition, abstraction, and algorithm? I mean, those are quite fancy terms for teachers that might be having just a cursory idea as to perhaps what a program is or what computers can be useful for. But they're the legs behind what programming is about.
So
Decomposition,
what
pattern recognition.
they are is really useful. And And there are also things that we all do without even thinking about them, hopefully. So you could think of it as ways of problem solving. So it's unpacking a larger problem into smaller problems, so that would be a bit of decomposition. Abstraction could be abstracting, I'm using the same words here, it's not very helpful.
Recognizing the same pattern to do the same thing again and again in different situations.
So then we have pattern recognition of actually identifying that pattern, or the algorithm side of coming up with a pattern to do something.
And the algorithmic design kind of combines the three previous things together. So the steps on the website are kind of listed in order. You need to first go to decomposition to break down problem into steps. Then you can recognize that there are certain components that are reusable. That then goes to the abstraction level to realize that, okay, I can use this little bit of this widget, you could call it, to say that this little bit of code solves this particular task, and algorithm design is combining these widgets to do a larger task.
And pattern recognition, Tim.
I think you cut out there.
Do you want to ask your question again?
What about pattern recognition?
I wonder, because I begin to suspect when I hear these terms that they're really something that we've been doing long before we invented the electronic computer. Is that the case? Because didn't it all just happen in the 60s with the nerds and electronic computers and transistors?
These concepts have been applied to maths and other disciplines for many, many years before computers came into the picture. It's to be able to actually do algorithmic design, which is something that pops up in maths as well quite a bit. You need to be able to kind of break down your problem and identify subcomponents. It's kind of similar in chemistry as well, or in physics. Hey, certain little situations or certain little groups of compounds or formulas or things like that can be used to put together to solve larger problems. Pattern recognition and decomposition are probably the things I find that people find the hardest to learn out of the four of those. The things that I find are quite hard to teach relative to the other two, and there seems to be somewhat of a you give some kind of intuition for them, which I think a lot of kind of problem-solving maths and things helps with.
So if they're difficult to teach, what have you found works, or is it just building upon that innate kind of knowledge that the students already have, that Grok-ness that they already have in their understanding?
It is a hard question to answer. So I've, apart from my high school teaching via the Challenge and via NCSS, I've also taught at the University of Sydney for the last 8 years. Wow, that's a long time. Sorry, the last 8 years. And,
so old.
Yeah, and I've taught from first year to fifth year during that time, and it's a problem that exists across all of those levels, from both year 3 people in grade 3 in the Challenge, all the way up to people in fifth year university. But these skills are very hard to teach, and it's something that you kind of get just by doing. You get better and better by practice, and so the way I try and do this is by having lots of smaller problems that kind of allow smaller but similar problems that allow you to kind of, just by the nature of doing those smaller but similar problems that have a small change between them, you can kind of, you almost learn by osmosis pattern recognition, having these small deltas between problems and kind of build up from there. Obviously, in larger concepts, you need more smaller problems or different kinds of deltas between your problems, but that's kind of one of the approaches that I take to help with learn pattern recognition and decomposition.
We can start teaching those sorts of concepts very early and in very fun situations, though. So I'm sure some of your listeners will be familiar with B-bots, but they're small computerized bees, I guess, quite similar to Papete's logo turtle robots, that you can program to move around a floor. And there are lots of great exercises you can do with these with very young kids, working up to, if we introduce a problem of, let's get this bee to get out of the maze, how do we decompose the problem? How do we come up with a pattern to move around between the blocks that we've put in to make it more difficult? And how do we come up with a more general solution to maze solving? And you can do that with kids from kindergarten up, and they have such a good time doing it.
And if we, in a sense, we're still playing with programs, is it possible to look for other ways of learning that don't necessarily require you to have a piece of electronics and tools or access to a computer?
Well, with the Bebot example I just mentioned a second ago, an even possibly more fun example would be if the students, instead of moving around the bee, actually get to tell their teacher where to go and where to move throughout the maze. That tends to, for some unknown reason, bossing around the teacher seems to ignite their enthusiasm.
Especially if they're wearing a bee costume.
Oh, yes.
Or a turtle, just for balance.
But there are a lot more. There are a lot of other activities. So the CS Unplugged, which is a resource put out by Tim Bell from the University of Canterbury, if I'm not mistaken. I'm sure it's been mentioned many times, but it absolutely deserves mentioning again. It's got some really, really great activities that don't require computers, that start to bring in these computational thinking aspects of algorithm design, of decomposing problems, of pattern recognition, and of having fun too.
And I guess that's where it comes down to. We're looking at being able to do that sort of mathematical calculating and problem solving, and that picks up with the first one. What about abstraction and algorithm? They sound a bit more cryptic.
They may sound complex, but they're really not. An algorithm is just another word for a recipe in some cases. So it's a process of solving a problem, of the steps that are required in order to solve that problem. So if you're coming up with an algorithm for making an omelette, that's surprisingly similar to a normal recipe. Coming up with a recipe to solve a question, to solve a problem, is all an algorithm really is.
Next time I make cupcakes, I'm calling it an algorithm for sure now.
So there's actually a great bioinformatics textbook which is used in one of the subjects at the University of Sydney, which does introduce what is an algorithm with a recipe for pumpkin pie. And as a celebration for finishing the subject, one of the students did bake said pumpkin pie, and it was delicious.
So if it's a recipe, and I've just thrown up here just some simple algorithms, including the Gilger algorithm here, and the friendship algorithm, which I think people might remember from, I think it was Sheldon from Big Bang Theory. They're just, I guess, recipes and ways of solving problems.
Yeah, it's an unambiguous set of repeatable instructions. So given a problem definition, being able to follow through some steps one at a time that are unambiguous at each point in time, and get to the same outcome, or get to an unambiguous outcome, I should say, given a set of inputs, which is just like baking anything or making anything food-wise.
And reflecting on the Bebot kind of scenario with the younger learners as well, that unambiguousness is really key, because you can't say just to the teacher or the Bebot, just go that way. Turn around now. You actually have to provide those specific, detailed instructions, and that helps you build up towards coding in the future.
But that's kind of where we're heading now, Amanda, because I'm thinking of Conrad Wolfram, and he did a lot of work with his database, being able to ask plain text questions. And if you look at the way that search engines have evolved, the way that Siri doesn't just simply respond to voice commands, it's actively listening to you and deconstructing your language to look at your intent from past behavior and other patterns. perhaps we are heading to a stage where we'll have a new layer of programming which will be plain text and being able to structure your agents in ways that are a bit more familiar.
Ooh, now here's where we're going to get to the pushing the limits of the 8-hour Hangout limit, because Tim and I could talk about computational linguistics.
Sorry, I knew that was coming.
For quite a long time.
Yeah.
What is that? Tell me more.
Oh no, we've gone off track already. So Tim and I are both doing our PhDs in computational linguistics, which is a subfield of artificial intelligence, and it deals with human language like English, French, Cantonese, and dealing with computers or teaching computers to actually deal with that. So as you can imagine, there's a lot of pattern recognition that's involved with that, a lot of coming up with algorithms to solve particular problems, and every time you've used Siri or a Google search and come up with really rubbish results, there's someone at the other end saying, if only we could make this better, and writing PhDs trying to come up with better ways to do things.
I see that need. Me and Siri just really don't understand each other at all. She doesn't understand me. I try. Yes.
But see, Amanda, I've bought myself my new Volkswagen Polo, and I've got my Bluetooth and my handset, and I can actually have a conversation with my car and say, good morning, and she corrects me, usually if I get it wrong, and says, no, it's actually 12:10 p.m. But then I can have this, what is my agenda for today? Can you call my mother? He said, I don't know who your mother is. I have to spell it out. Oh, thank you. Shall I remember that's your mother? Yes, please. And then I could ask questions like, where is my wife? And then off it goes and does the search with the Find Friends application. And I think that's really powerful because you're starting into a layer of linguistics that people are a lot more comfortable with. Do you think that we'll start to see perhaps programming moving into that dimension where people begin to program in plain English? Or is that just a bit too loose and unstructured for you?
As someone who deals on a day-to-day basis with the ambiguity in language, I think we're a long way from that.
As I said before, with the recipe idea and how to set up unambiguous instructions, apparently language is not ambiguous. Not unambiguous, sorry.
Inherently ambiguous.
Yes, inherently ambiguous.
I've heard Gordon Ramsay, and even his plain English recipes have all sorts of interpretations by various chefs in a kitchen. And I think there's a lesson there. So we're looking at bringing... That's right. Did you really mean to burn this or just crucified?
So I think part of that aspect is a lesson that students really need to learn when they go to computational thinking, when they go to approach programming, is that people are smart, but computers are really, really dumb. Really dumb. They're very fast, but really dumb. So they need this really unambiguous, precise instructions in order to do anything at all. And yes, thankfully we can get meaning out of things that computers can't, or can't necessarily find the right meaning. But it's a fun lesson to learn just how dumb computers are.
But it doesn't really need to have big nerdy people. I just want to mention Ada Lovelace. Are you guys familiar with Ada Lovelace?
Indeed.
Yep.
Now, I can see Andrew's smiling. Do you want to fill a bit about Andrew, who Ada Lovelace was?
The desperate question is, was she Babbage's mistress or not? But she's certainly credited with being the founder of programming, using those Hollerith cards. Not Hollerith cards, Jacquard cards. That's the way.
And being able to actually recognize a person to actually write this algorithm intended to be carried out by a machine makes her the world's first computer programmer. In 1815, she was born. That's really quite powerful. In that sort of history, and being a significant sacred mover in thinking about mechanical processes for solving problems. I mention that because sometimes it's not all that evident that what we've been doing has been done in the past. There's nothing that perhaps is that unique that hasn't been done before, and it wasn't waiting for the electronics generation. Perhaps we can solve these problems quicker than sort of scribbling them out on punched cards. Paul asked a question on today's meet. Problem-solving strategies in computer science need to be explicitly taught, not based on hope. I guess Ada was sort of thinking very clearly, logically about what she was doing. But I know that my students bang away on those keyboards, and they seem to actually try to hope that their programs will work, and in frustration say, this comma doesn't have to be there. I think it should be there. Why doesn't the program accept it?
One of the lecturers at City Uni has a phrase for exactly this situation. She calls it coding by random miracles. Changes slightly, does it run yet? Oh. Changes slightly, does it run yet? Oh. Yeah.
But it is a stepwise progression. I mean, that's how I started to learn how to program in BASIC on my Apple IIe.
I think the distinction here is not is the difference between learning the syntax of programming and actually learning the computational thinking behind it. So it's very difficult to if one really struggles with the concept of how do I have a problem that I can then break down and solve, teaching that is very difficult. Teaching students where to put the comma or where to put the semicolon is much more fiddly, but much easier. And that, in terms of computational thinking, is almost completely irrelevant. It's the meat of really designing the algorithm to solve a problem that's the interesting part.
Something we're trying this year in the challenge for the first time is trying to do exactly that. So have a way for students to be able to actually express purely the logic of their algorithm without having to worry about commas and your semicolons and your indentation. Yeah.
So the computational thinking elements is what makes the Grokness in terms of learning.
I would say so. It's also what makes it interesting. So if I taught someone that in Python an if statement is the letters I and then F and then a specific condition and then a colon, that's completely boring. But if I teach someone to write a problem that write an answer that solves a problem of is that password correct or is it not correct, then it's immediately interesting for the student. Or more particularly, our questions are far more interesting than simple if statements once they've learnt a little bit more of estimating the speed of light using marshmallows in a microwave or writing poetry using tweets. So really interesting things. And learning the programming elements is a necessary element to that, but it's a skill that you learn that you can then use to fix those, to answer those interesting questions of computer science, of computational thinking, and of problem solving and algorithms.
So it's not so much about learning a particular language. Like I learned Python, it was awesome. It's more having that context to apply it to the problems to solve, going through those components of computational thinking that we've already discussed this evening.
So we are quite biased, and we think that Python is an excellent programming language for students to learn.
It's not biased, it is.
Within context.
It is. But no, absolutely. The interesting, important elements that the students are learning is not where to put the semicolon. It's the concept of control structures, of getting the computer to do what you want to do, of being able to create solutions, not just use technology, but actually create it. That's the key thing that we want people to do.
And it's good how you actually build it up. And I'll come into that in a moment. I'll get you to talk a bit about the what you've done with the NCSS challenge. I've got to thank you too, if I can, and a quick plug. A thank you to Nikki, who helped me last year when I was coming up some ideas for a research project that I ran, which will now be published at the ACCELN 2014 conference. And I was looking at conceptual understandings with Paul Chandler, and we were really interested in asking some simple questions. Nikki, you helped me with 5 of the questions. We got so much useful data, we actually managed to just publish this entire paper on the first question. But
Excellent.
one of the things that it's been really good. I haven't even had time to look at the other ones. I reckon there's a PhD sitting in those questions. But Nikki, one thing that really struck me is the misconceptions that students actually bring. The funny one first was that there was, I remember students asking me when they're looking at Python, "Where's the cat?" and I'm looking at them thinking what they're talking about. But now I think because they've all had these various experiences with Scratch, they're looking for a cat to jump out and run across and help them.
Why not a snake?
And another student,
wouldn't that be contextual?
yeah, well, furiously looking, how do I change the color? Well, if I type it in Word, I can change the color of these things, realizing that it was the compiler that was changing the color. No, it was well, maybe they had to change the color to make things work. And lastly, and I want you to relate to this one, a student who is actually, how to describe this? They actually, the program is aware of itself in its entirety. Now that might seem odd, but you know it as having a very linear structure where things are being solved in a stepwise order. It's not necessarily aware of things that are coming up ahead. How do I describe that?
The program is not omniscient?
Yes. Now, how do you cope with trying to tackle some of those conceptual understandings and misunderstandings about how computers work and how programs actually work?
We try a lot of things and hope that one of them works. So first off, the way that we've got the challenge structured, students start off with the notes where concepts are introduced really gently and hopefully interestingly as well. So there are interactive notes, so the kids get code snippets immediately that they can muck about with, run, get immediate feedback on what change that's had, what effect that change has had. So they're already engaging with the content from the get-go. And we really do want these kids to muck about with these code snippets and break them and see what happens and really not be worried about getting their hands dirty, because if they engage on a deep level, then they'll get that intuitive understanding, which is the aim that we want. So we start off with these notes that are actually, you know, they're small, they're easy, the kids actually read them, we're amazed, we're pleasantly surprised, let's say. And then we have questions that immediately test the concept that's been introduced in those notes. So the kids immediately get feedback as to whether they've understood what they think they've just understood, and they know where to go in order to get help in terms of go back a couple pages and read those slides and see whether it's a conceptual error or a really bigger error, and if it's something like, I need this string to go green, how do I change the colors, then hopefully those students log on to the forums and ask other students for help or ask our tutors for help. So we have a veritable army of tutors sitting on the forums answering questions pretty much 24/7. So we have good coverage this year. So we've got lots of tutors in Australia. We've got a couple in Europe. We've got a couple in America. So no matter when these kids have questions, they should be able to get an answer pretty promptly. And that's a good way of avoiding a lot of these kids from getting completely stumped and feeling so frustrated that they give up. We have help immediately on hand to really make it as positive an environment as we can.
Is
that a problem in the past in the way people have thought?
I caught neither of those, sorry.
In the past, is that a problem in the way it's been taught, that people are easily disillusioned, they kind of get thrown in the deep end, it's been made to seem too easy by following a strict set of instructions? Have we taught it badly?
I would certainly say that. So in terms of learning to program, certainly I was disillusioned when I tried to learn to program. And things were either too easy but useless. I couldn't see where something like Scratch, I couldn't see how that would be a useful thing in my day-to-day life. I didn't know how to translate what I was learning out of that sort of an environment into a real programming environment, and I will use those scare quotes deliberately there. But then it's very difficult to say to a student, oh, okay, you're in grade 6 now, that means we're going to start with you with learning C. Off you go. This is how you write a compiler. Off you go. This is, you should learn programming the real way, because obviously that's not going to be a sensible way of getting them to have these small victories to keep them motivated. So I think that's one of the best things about the way the challenge is structured, is that every student gets small victories as they get a question right, and they get points, and they might make it to the leaderboard and they might not, but they'll get a badge, and they'll really feel the successes more than feeling the failures, because we don't want oh, my program ran and I got a syntax error to be a failure on the student's part. It is most definitely a situation of, remember, the computer is dumb, people are smart, we have to be particularly pedantic about what we tell the computer to do. So it's about encouraging those victories and really celebrating every success that the student makes.
Another thing with the small victories is that we try and make each of our notes just one or two paragraphs with a runnable example. So on each single page of the notes, you can actually have a distinct concept, try and learn exactly that concept, no more, no less, and have a runnable example so you can muck around with it, break it, fix it up, try some different inputs, different outputs, and see what happens. So you can really kind of grok that particular concept.
I've got a lovely quote here from one of our listeners, Paul. I'm just checking on his surname. It's about abstraction, Big Bang Theory. It's a metaphor for when we take something and we've overly simplified it. I remember when I was a chemist that I had this feeling that they were trying to fit y equals mx plus c to every phenomenon in the universe. For those listeners not maths inclined, that meant that everything had to fit on a straight line. And the joke becomes from the way that theoretical physicists work. And if I could, and I'm reading this out from Wikipedia, but I think it's very good. The milk production of the dairy farm was low, and a farmer wrote to the local university asking for help from academia, and a multidisciplinary team of professors, which included some IT programmers, was assembled, headed by a theoretical physicist. And after 2 weeks of intensive on-site investigation and modeling, they then returned, and with the notebooks crammed with data and computer models all set up, and the task of writing the report was left to the team leader. Anyway, the physicist returned to the farm, saying to the farmer, "I have the solution, but it only works in the case of spherical cows in a vacuum." Now, I wonder about the real-world nature of all the problems we have to actually solve here. Does it have a place in the real world that we know how to program?
Oh, hang on. I have a solution for that. It has a place. It's in years 7 and 8 under the Creating Digital Solutions part of the Digital Technologies curriculum. So they talk about, well, here we go, define and decompose real-world problems, taking into account functional requirements, etc., etc.
Look out, Amanda. She's clutching a national curriculum model there.
On paper, no less.
Paper. Well, it was really hard to hold a smartphone up to the screen when anyone can point to that and say, "Look what I just Googled." No, I think that shows enormous currency. So very brave of you there, Nikki. But that's
so yes, definitely. There are so many real-world problems that are, I'm hesitant to use the word solvable, but many of them are solvable with programming. I'm not saying that programming in computer science can solve every problem. They will not be able to, well, maybe that they'll be able to tell you what the weather will be like in a year's time, but it's unlikely. But yes, absolutely, real-world problems, computer science, we can make a real endeavor to fix things.
And what I love about the digital technologies curriculum throughout the whole thing is the way that computational thinking is embedded within it. And you've got that context of students are solving problems, and the nature of those problems varies as students get older or they learn more things to apply them to as well. And so I think, Nikki, it's something that you said before, which was they're creating. They're not just using IT, they're actually creating new programs, new IT, new things in their world, which is pretty awesome.
So,
and never been done in our curriculum before.
No, it means it's quite exciting. I'm excited and disappointed that I don't get to teach a class, but we get to teach a couple of 100 classes around Australia, I guess. So that's something. But I really like the part of the challenge that is a student is faced with 5 to 8 questions per week, depending on what stream they're doing. And these questions they might seem a bit silly. Some of them are very silly. But the real-world applications to the computational thinking that they've been learning. And sometimes it's a bit of a stretch of real-world. I don't expect every student. So one of the questions last year was to write a little program that would help you learn lines for the school play. And it would tell you whether or not you'd gotten the line correct, or give you a prompt for the next line if you were stuck. That's obviously not something that every student would find themselves in need of, but it's a real-world application that students can see, hey, this is something that's real, that I've learned how to do, that I can write all of. I created this entire program, and it does something that I may find useful.
Yep, we have some other students who've been doing grade calculations to work out what their final grade at the end of the year would be. And another question we had last year was for Australian students was a UAC calculator. So it was a question where you were given all of the students' final marks for all their subjects, and it was to rank the students in terms of what their UAC ranking would be. So again, a lot of the problems that we come up with for the challenge are some level of abstraction away from a real-world problem. In the UAC case, it was actually almost real data and a exactly real problem. I think it's pretty cool. One of the reasons why we find the questions very interesting is that we try and model them all on real-world scenarios.
That's way cool. Have you found that some types of questions are more interesting for students, or they seem to be more into than others?
It's actually really interesting. We find, so at the end of the challenge we do a survey and ask students what their favorite question is and their least favorite question, and also the hardest question. And almost invariably the favorite question is also the least favorite question and also the hardest question. So I'm not really sure what that says about students, that they actually like being challenged, or perhaps only the ones who answer the survey like being challenged. But nevertheless, some of them do, and they find these questions hard, and they struggle through them to solve them, and they come up with a working implementation of preferential voting, essentially, which is great. It's amazing. We've had some interesting questions, themes a couple of years. So last year we had a couple of questions on Pac-Man, writing Pac-Man AIs for the ghosts. They were quite popular. I still get comments of former students who I think they may still get night terrors about the parsing questions that we put in the advanced stream a couple of years ago of essentially writing a parser for combinatorial categorical grammar, which is a specific grammar formalism that Tim and I are using in our PhD theses. It's real world for us and for these students, and it was definitely a tough question, but they loved it and they hated it at the same time, and it really had a lasting effect on these kids.
When I'm coming up with questions, a lot of the things I do is I think about what I've written in the past day. What task have I tried to solve with this particular data I'm trying to manage today? And I can normally create a question out of it. It's very real world.
Do you see a future where the students will be able to bring their own problems to the mix to present and get others to solve?
Ooh.
That sounds excellent.
That's a good idea for maybe a week 6 activities and extension.
Yeah. No, definitely.
I should have patented it.
You're right.
So we had a class, and I have to get this right, a class that did another one of our competitions, and then collaboratively wrote a chatbot as a class, and quite an intelligent chatbot. So I'm not sure if that was a challenge that the teacher gave the class, or the class wanted to continue what they were learning initially, but certainly there's scope for, once the kids are trained up with these skills, then they can challenge each other to solve their own problems.
There must come a time that you begin to see connections with groups that it's really hard to come up with a problem-solving or a sorting strategy that hadn't been thought of before? Or is it really that infinite that you'll be taken aghast at a new way of looping programming code that you hadn't seen before?
I don't think we need to come up with novel ways of writing for loops, but novel ways of using them, certainly.
Okay.
The options of using computer science and utilizing programming are limitless.
Well, I'm going to give you something here that's a little bit different, and it's the idea that perhaps is knitting a form of programming. And so I'm going to throw here a bit of knitting code. And you can see here the lines of code here. Chris is probably familiar, and a shout out and hello to Chris Betch, who's joining us here.
Hi, sorry I'm late.
This is
Seasoned knitter, no doubt.
Yes. Using number 3 needles and RB wool cast. It's all written in code. P3KLP. Obviously these are variables or subroutines. The Perl subroutine, knit 1, loop 1, drop 1, and then is that a form of programming?
Of course it is.
Or is it just about code? Or do I have to actually solve a problem?
The problem is clothing, and as someone who's tried to follow knitting programs like that, I've found that the wise mentor of my grandmother has been very helpful, and sometimes you get stuck and it doesn't quite work and you have to undo it, debug it, come back again, rebuild it. The only thing is you can't have automated loops that just do themselves, that are repeatable.
It's a knitting machine, isn't it?
Indeed. But maybe we're the knitting
you can
machine.
program knitting machines. Like you literally type into knitting machine a formula exactly like that, and it does the loop and follows the instructions bit by bit to get your patterns.
I suppose what's going to make that into a program is going to be more than just a series of bits of code. And coding is much more than just strings of lines of a program. It's about being able to connect these things and use them in ways that are different and new for solving problems.
Yeah,
good analogy, dude.
I'm just going to see if I can leap in for a minute. I'm very interested in that knitting one, Roland, because it really is a procedural approach, step 1, step 2, and so on. I'd be very interested in Nikki and Tim's approach, and congratulations both of you on your hats in your profile pictures. I think they're both magnificent. Are there ways in which we should be using computers in non-procedural ways? What do you think?
Example?
In an education environment or in general?
Well, I'm particularly anxious, if you like, about the new quantum and optical computers, where they seem to have the potential to try all the combinations there are simultaneously. You can do a bit of parallel programming in Scratch, which is great because you can get it to do 3 or 4 lines of code simultaneously, but it's not quite to the same scale as these bigger computers which are coming down the pipeline towards us.
That's a multifaceted question.
I love that you're drawing a fine distinction between.
Okay.
I love that you're drawing a fine distinction between a large multi-processing computer and Scratch.
Well, yes, true. You can get some multi-threaded Scratch programs, but of course each thread is procedural. We've had declarative programming before in Prolog, which is old hat now, but that had some fancy stuff inside it. But it seems as though these modern computers, which I think the Japanese have already got some quantum encryption networks already set up in Tokyo, so they're not, popular on Harvey Norman's shelf just yet, but they're certainly coming. I'm just trying to ask the general question. A lot of computational thinking seems to be linked to procedural programming. Nikki and Tim, is that your view?
A lot of it probably is, yes.
The concepts of computational thinking aren't limited to procedural programming. They're just currently most useful in a procedural programming
easiest
environment.
to explain sequentially. Like, it's the most novel way you can try and express something as a series of steps. It's very straightforward. You can see it. I mean, other paradigms of traditional computation, such as functional programming, object-oriented programming, declarative programming. These are all still used today, very much used today, but they're not necessarily as concise in their ability to express the way you solve something logically. Once you have the idea of the logic in your head, expressing them in those languages might be very concise, but the reverse process, for someone who doesn't already know the language, can be very non-obvious, if that makes sense. They're reading some functional code and trying to derive the logic from that is not as easy as going from the logic to the code necessarily. And one of the advantages of procedural programming is literally a set of strict steps, one by one by one by one. And if worse comes to worse, you can just follow them one by one and you can derive the logic that way.
But it's interesting you should say that, Tim, because quite often I can look at a program and say, I don't speak your particular language, but what I want your program to do is this. And then the logic spills out.
Yep. So a well-written piece of code in any paradigm should be able to be easily, what's the word I'm after? Reversible? No, inverted maybe, between logic and code.
Reverse engineered?
Yeah, close. Reverse engineered. A lot of code people come up with is not that. But if you actually are able to express your ideas clearly enough that anyone who doesn't know the language can actually read the logic straight from the code, you've done a good job, in my opinion.
It's interesting you say that, Tim, because again, one I've often tried to psych students up for the NCCT challenge. I've had fun actually showing them a TED Talk video which looks at problem solving, different strategies, starting from the solution and working backwards. And the classic sort of little mental games you can play to sort of reconstruct the logic required to solve a particular problem.
Yep. That's the common technique that's used in maths as well, is starting with a solution and working backwards to try and get... If you know what the answer is in a maths problem, and you're halfway through your working and you can't see how to get to the solution, it's sometimes easier to actually go from the solution and work backwards to see what the missing steps were.
Yeah, it's interesting that encryption, of course, is the classic situation where it might be easy to go one way, but very, very hard indeed to go the other way. You don't want anybody to break your encryption.
On the quantum cryptography point that was mentioned, on the quantum computation point that was mentioned before, we're still a little bit away from being able to do anything real with these at a non-government level or non-military level. The technology is not quite there yet. But once we do, it's going to completely, if and when we do, it's going to completely change the way that, not computer science, but the way that programming is done, probably. The main advantage that quantum computation has over traditional computation is that you don't have this on-off idea, this Boolean idea where something is either on or it's off. You have any amount of values between on and off that you can express simultaneously. And as was mentioned just before, you can kind of express all certain states of the program can be in simultaneously, and things that used to take a very long time to compute now are very, very quick. So the example from before with encryption was that almost all of modern day cryptography is broken if a quantum computer exists. The only reason why the vast majority of cryptography works these days is that you cannot factor the multiple of 2 prime numbers easily. If you have 2 prime numbers, you times them together and you get the number. Getting from that number back to the 2 prime numbers is very complex. It takes a very long time to compute. With a quantum computer, it's almost instantaneous, that step. It's a very easy computation. And almost all cryptography in the world relies on that process.
I'm sure if some of the people who participate in your challenge, do that bit. The essay will be after them. But look,
Yeah.
I'm pleased to hear about your project, and I'm just wondering if you're able to tell me, perhaps Tim or Nikki, how many years into the future do you expect this project to keep going?
Mm.
Oh, well, I plan on living for another quite a large number of years. So quite a large number of years.
N.
Depends when the caffeine overdose hits in.
Let's call it N.
And so hopefully I will be handing my thesis in March. I feel the need, so there's wood around here. And then working on Grok full time. So coming up with not just more exciting challenge questions, but also expanding into writing more open-ended projects, more competitions, more courses, more languages. We want to do a whole bunch of cool stuff with web development and automatic testing of web development, which is exciting and hard. Most things that are exciting are also hard. We've got good ideas for. We've got lots of good ideas, so I don't see.
Lots of ideas, just not enough time at the moment to pull them off.
Yes. So as soon as we have more time, we'll use that time, and then want more time, and extend into the future indefinitely.
Sounds as though you're pretty well wedded to Python. I know that in Tasmania we've been having perhaps the endless discussion of how many programming languages should students learn. You've mentioned Scratch. Why is Python better than Java, or would you like people to learn both of those?
I think people can learn both of those eventually, but I would strongly recommend learning Python at school or even at university. Certainly as an introductory programming language, I think it's a lot better. So one of the main differences is that Java is a compiled language, whereas Python is interpreted. And what that means is, in Java, I would write an entire program and then run a compiler over it and then run it, which is sensible for some things. But Python, on the other hand, is interpreted, which means that every line I enter is interpreted sequentially, which means that there's this great thing called the interpreter, which I can just run and muck around with really small code segments and really engage with that content. What does this particular line do if I change it like this? And I think that's a really powerful tool for kids to have at their fingertips when they're learning to code and when they're learning about these things.
How does that compare to Ruby?
Tim, why don't you take this one?
Everybody's got their favourite.
Ruby is also an interpreted language. One of the main advantages I can see for the Java v Python debate is that Python's predecessor was designed as a teaching language. So designed specifically to help people who haven't learned to program before to learn to program. And Python, in both its 2 and its 3 variants, exhibits a lot of those properties of the easiness to learn as a first language. Being clear, concise, not being burdened down by a lot of syntax, such as semicolons and squiggly brackets, and having a very easy to read English-like form. And don't worry, these debates also happen at university all the time as to which language to teach first years. It's an ongoing, never-ending debate.
Yep.
The reason I was curious, we finally started a programming club at school, and I'm not running it. We have a maths teacher who used to be a programmer who runs it, and I walked in to have a look and see what they were doing today, and they were all working in Ruby, because I think that's his favourite language. So I was just curious to know what your thoughts were on that.
It's very hip right now. Yes, certainly a lot of momentum. It's quite a cool language, but it's got my tick of approval compared to Java. So yes, there's
Have you
that.
guys messed around much with? I think Google released it as a 20% project time. Pencil code. Have you sort of messed around with that at all?
Pencil code, huh?
Yeah, I'm looking at it as a sort of a, after Scratch and before Python kind of thing.
Okay. It looks a little bit like. I'm looking right now, but it looks a bit like. Sorry, I've had a mental blank on the program that it looks like.
I can't help you.
No, that won't help at all. Processing, I think it's called. Yeah, processing.
Yeah, it does look like processing.
Yeah. Okay. I was talking to a Googler from Mountain View the other day, and she was saying they at I/O recently they had an event called Made with Code, Did you come across that? And they got I think it was something like 200 students coming into the Moscone Center in San Francisco, and they had like a full day's workshop of just making stuff with pencil code. And I think if you actually go to GYM as in gymnasium, gym.pencilcode.net, there's a whole bunch of sort of project ideas in there that I thought were interesting, you know, just in terms of the stuff you're doing with Grok. I thought it was another interesting view of how people are sort of taking on the programming challenge idea.
Yeah, I mean, it looks, actually now that I'm looking at it, it looks like a combination of processing and logo, and I am all in favor of logo, so yeah, no, it looks quite cute. These examples look like they're teaching geometry, which it gets me excited as well.
Yeah. Actually, if you go to Gym Stage, gymstage.pencilcode.net, you actually see all the projects the kids made in that workshop day.
Okay.
There's some really interesting stuff.
What we have expanded into, which is exciting, and also came out of Google, is Blockly. So Tim mentioned this briefly earlier, is that we've got a visual programming environment similar to Scratch that students can use to drag these blocks into place and solve questions. So they'll be solving exactly the same sort of questions as in the Python code, but I wonder, but as they're drawing these blocks into place, as they're dragging and dropping them, we're also generating the Python code at the same time.
That's amazing.
Yeah, we've.
I don't know, can you see it on my screen or not?
Yep.
Okay. This isn't public yet, but it's getting there.
We've got another 2 weeks, and then it will be.
Yeah, so you have these blocks. They represent fragments of code that you kind of snap together to form your problem over here, and down the bottom it generates the equivalent Python code. So you can either choose to write Python code, or you can do syntax error-free programming by dropping the blocks together and focus purely on the logic of what you need to do by dragging the blocks together, and you can see what the corresponding code is that gets generated.
Tim, is it symmetrical? If I write valid Python code in the bottom section there, will it actually update the blocks in the top?
In 2 weeks' time, it will be.
Oh, that's very clever.
It's not currently.
That step is a lot harder, but we're stubborn, so we'll keep working on it.
So is that implying then that the underlying language behind Blockly is in fact Python, or have you done some sort of black magic?
It's language agnostic, actually, but there's a little bit of magic that needs to happen together to work in a particular language. And
could you apply that to other languages as well?
Yep. So Blockly out of the box supports JavaScript, Python, and Dart.
Yes.
Oh, really? Wow, that's very cool.
It's quite easy to add other languages if you so desire. Sorry, say it again.
That's impressive.
Dart is essentially JavaScript, is it not?
Yes. Yeah.
That is really cool.
Very neat.
So we're really excited about that, and about getting younger students to start dabbling with computational thinking elements, and to really simplify that the progression from a visual programming language. Scratch is great for getting kids excited about computers and to get them to play around and explore, and then to really bring in that real-world problem-solving element. We need a simple way of transitioning between the visual programming and general-purpose programming, as is in the digital curriculum guidelines as well. So we're really excited about the visual programming translating to Python immediately, so that transition is made as easy as we possibly can make it.
Do you think that will be released in some sort of a tool where it's just like a general programming environment rather than sort of your competition environment?
And that depends on the sorts of magic.
You mean just being able to construct code using Blockly, you mean?
Yeah, I mean, if I'm teaching a group of students, say, year 4 or 5 students about Scratch, and then as they sort of move on to year 6 or 7, I want to take them on to the next step, and the next step might be that sort of Blockly with the Python, undertones. But right now, the only place I've ever seen that is in your competition environment, which is brilliant. But I'm just wondering, as a general purpose teaching tool, whether
that list of things to do that we don't have time to do, it's on that next year. And we'll
Nikki,
see. This is the first time. This challenge will be the first time we've run with this Blockly environment. So it'll be interesting to see how it goes this year.
So we want your feedback. Give us your feedback, please.
Okay.
Will do.
Nikki, I'm just wondering if perhaps we could talk about the NCSS challenge that you got with your Grok Learning. It kicks off in a couple of weeks, and if anyone's been listening, this is a wonderful project, great for teaching programming to people on small islands like the UK or Tasmania or Australia. Nikki, share what teachers can do and how they can join in.
So, step one, if a teacher is listening and you'd like to, the best way to find out about it is to actually get in there and have a go. So if you send me an email at info@groklearning.com or just log online and send us an email via the inquiries button, I'll send you a free invite and you can muck around and explore for yourself. But the challenge itself starts in 2 weeks' time on Monday the 4th of August. And last year we had over 6,000 students, mostly from Australia and New Zealand, participate. And it's the most amazing, engaging experience that happens each year, with possibly the exception of the summer school, which we've talked on as well, but doesn't scale to 6,000 kids. So what happens is each week there are a set of notes and questions released. I've mentioned these things earlier, but I'll summarize it now. And the kids have until the end of the week to answer those questions for points. And the points they get on the leaderboard, they don't win a car, but they do win imaginary internet kudos, and that seems to be a very powerful motivator. So the questions are really fun. We've mentioned a few things. I've got some really cool ideas for questions this year that involve a whole bunch of cool physics. I've got some Aboriginal Indigenous language questions lined up. Maths, language, science, art, history, geography, geology, music, anything you can think of, there'll be a question in there on it. And the questions are really fun, so the kids want to solve them. So there are notes, there are questions, there are tutors to help out if the kids get stuck. They can ask us for help. They can ask each other for help. It's actually really amazing. Chris, some of your students are really phenomenal in helping one another on the forums. I'm continually impressed by how polite they are talking to one another and how spot on their advice is as well. It's really good to see.
Really? Okay, there you go.
There you go. So it starts in 2 weeks. It runs for 5 weeks. And it's a whole lot of fun. And we've got 3 streams of Python from beginners to intermediate to advanced. And the advanced questions are hard, very hard. They will extend your brightest students. And the beginners is a gentler introduction. And again, now this year for the very first time, we're running a Blockly course as well, so integrating the visual programming language. So we're very excited about that. We're excited.
Oh, for any teachers thinking about doing this and listening to the broadcast, do the basic questions on the Sunday before you come to class, or just play dumb and pick it off the smartest kid, because the tough questions are bloody impossible. Gosh, it does me head in. I'd rather spend the week doing Sudoku than some of those.
I'll add that as a teacher, you can see your students' submissions.
Yeah, I learned a lot from them.
Yes, true.
I did the beginner's stream last year for the second time, and I think I got about, and I also did the intermediate. I got about, I don't know, I forget now, probably 3/4 of the way through that, and I had a crack at the advanced one, and that was, yeah, like you say, that was really hard. It's a great experience, though, and so well put together. You guys deserve a huge kudos for just the think through that you've done to create that environment where you can both learn and compete and play and collaborate all at the same time. It's just a really nice environment.
Thank you. We like it.
I love the way you're open about it. Is there actually an age limit to the students that you're intending to appeal to?
So we're reluctant to put an age limit on it for a very quick story I'll relate. So it was initially for high school students only. And then at the end of one challenge, we got a teacher called up and said, I have a confession to make. I lied. One of the students is actually in year 6, and I didn't think it would be a problem, but now he's on the top of the leaderboard in the Year 7 and 8 division. So we extended it to Year 6, and then we started getting Year 5 students doing it, and then Year 4. And for the first time, we had Year 3 students do the challenge last year. So this is pure Python doing those questions, and look, they struggled a little.
Wow.
They weren't familiar with some of the concepts like division, which is involved in a couple of our questions. But they logged onto the forums. They got help. It helped that one of the kids in Year 3, her mum happens to be a computer science teacher. So you can imagine she got some private tuition and was able to really get a lot out of it. So Amanda Hogan, if you're here, there's a shout out to you. I know you know who you are. But Amanda was saying that her daughter really enjoyed the challenge of finding a question that she didn't know how to answer. That this is not something that she'd been exposed to before. Having something that was really tough and not knowing how to answer it and having to actually work at answering a question. So no, we don't have a lower age limit, and especially with the visual programming, I wouldn't recommend it for students under grade 3, but I've been proved wrong before.
Yeah,
fantastic.
We've already got some grade 3 people this year enrolled, so.
Wonderful.
I think given that the father of children's programming, Seymour Papert, was also a huge proponent of not putting age restrictions on things, and so I think that's very appropriate.
Agreed. It's very easy to sort of start boxing and making categories, and I like how you package it. It feels like a competition, but really it's a challenge and it's a series of hurdles. And I appreciate also the support that you've given the girls in my group, Nikki. It's made a big difference in increasing their confidence and feeling comfortable about going on with programming as a lifelong career. Thank you.
Oh, your kids are awesome. They asked the coolest questions when I did video hangouts with you.
They're a cheesy lot. Thank you.
How would you like to visit a school in Croydon, Nikki, and talk to the girls about programming?
Well, I don't do home visits anymore because there are too many schools. But I will do a hangout.
Okay. All right.
And I'm going to volunteer all of our tutors as well. So it's not just me who is this insanely excited about computer science and programming. All of our tutors are really, really awesome. They're all volunteers. They do this because it's fun. A lot of them were students themselves who did the challenge, who had a great experience, who went on to do computer science at universities around the country, and really love this. And they would be very, very happy to do a hangout with you and your students to get them enthusiastic about what a programmer looks like and what we do.
Okay.
Oh, that's one more thing I should mention. So we have these awesome sponsors for the NCSS Challenge, which is great, especially because they jump on the forums during week 4 and 5, and we get industry mentors. These industry mentors come in and answer these kids' questions. So there will be real live employees, engineers from Google and Facebook and Atlassian and WiseTech Global and NICTA and I should really remember the sponsors better than this, but a whole bunch of cool things. And the kids can ask questions about what's it like to be a programmer. Do I need to know maths to be to do well? Any questions the kids have get answered. So that's a really exciting reward for these students for making it to week 4 of the challenge.
Perfect.
I'm just conscious of the time here, and I just thought I'd start to wind up. And perhaps, I'm sorry.
We've got 8 hours.
We've got 8 hours. We could try it one day. Was it, Julie, who was it? We ran a 24-hour Skype-a-thon. Jennifer Ashby. We could run that one day and talk about computational thinking and linguistic structure in programming with quantum computers. For sit and hold that conversation for 24 hours.
Summer school all over again.
Funny idea.
Yes.
Then we can submit it for a PhD.
Yeah, we could go on forever, and I'm sure we probably will if I don't wind you guys up. But I just want to start with first names from left to right, and just some closing thoughts. And if you want to throw a question to the group, feel free to. Perhaps starting with one star of the Antipodes, Andrew.
Oh, well, look, thank you very much, both of you. It's been marvellous to hear that. I asked about the age because I was particularly thinking of recommending this project to my postgraduate students who are teachers in school. So that's where I'm going with that one. Thank you both, Nikki and Tim. That was lovely. Great.
I'll go for it, Andrew. I know that I've been actually using it for my student teachers, suggesting this is the lever that they need to use to get up to speed and to give you a real tool that when you go out and start teaching programming in schools that you can apply with your students. You're part of something bigger than just a textbook and a tutorial and a YouTube video.
We have a number of student teachers doing the challenge as students each year, so go for it.
Yeah,
so they'll be in good company. Thank you very much for that reassurance. Lovely.
Chris?
Yeah, I don't know what to say other than what I've already said. You guys will be pleased to know you've probably heard me lament on occasion that my school doesn't really offer any sort of high-level computing type courses. My principal came and saw me today and said it was being approved at the executive meeting tonight that we'll be offering a computing course of some sort next year that involves coding. So
excellent!
Awesome.
Congratulations!
Yeah, you keep banging away, maybe you eventually win. But so yes, so and this is, I mean, it's a great initiative, like I said, what you guys are doing with Grok. So well done.
Yep.
Now, before you go, Chris, you just need to, you missed out on some questions earlier, so you need to define decomposition, pattern recognition, abstraction, and algorithms. Go. Just kidding.
He's waiting for the infographic from the DLTV to hit the shelves.
No, I'd be prepared to have a go at all those things, but just not in the time we've got available.
Just watch back the earlier part.
Yeah.
And Christopher from the UK, obviously there's an international competition. Do you reckon we'll be able to rally some support from the UK?
Well, I was very keen on for many years. Seems to have dropped out more. The lunch is coming and the sun has come out.
Oh, that's lovely.
Oh, that's gorgeous.
Yes.
Haven't seen it for how many months? Well, we've had some snow over the weekend here, Chris, so I'll send it back your way come Christmas. Thanks very much for joining us, mate. And Nikki?
I hope my levels of excitement have accurately conveyed how passionate I am about not just computational thinking and computer science, but the challenge, Grok learning, teaching your kids. I want to teach your kids. So yes, I think hopefully that's come across.
It has.
Very good.
Trust us.
In buckets and buckets and buckets.
Don't forget the semicolon.
Squiggly bracket.
And Tim, you're the only other person I know who didn't blink when Andrew talked about non-procedural programming. The rest of us were furiously Googling to try and find something to explain that.
That's part of my speciality, unfortunately.
Any closing thoughts for tonight?
I implore everyone to try and do the challenge or try and incorporate, have a look at what we offer at least. We don't want to, we want to help you teach your students. That's what we exist for. We're not here to make a profit, we're here to try and actually help people learn and help students who who are struggling to learn and provide a way for people who don't have another option to learn as well. So have a look at what we've got and give it a go.
Certainly will.
Thanks, Tim. And tonight I learnt about programming, weaving together the landscape of computational thinking. I wondered if Nita's program. That's right. I wondered. Do Nita's program, or can programmers really knit? We scratched, we played the blocks, and we all felt good by looking at the national curriculum and spotting what we were doing there. I've had a wonderful night. It's run over time, but no apologies because it's a great topic, and I've got a great team on board. And you guys are what make it all happen. You've made programming really hip and exciting, and thank you very much for all that. And I'll pass to my beautiful co-host, Amanda.
She is looking lovely tonight, isn't she?
She is radiant.
Oh, thank you.
It's the headphones
No,
that do it.
I'm lost for words. Yes, it's these chunky headphones. They're delightful. No, thank you so much, Nikki and Tim. It's just been an amazing hangout tonight. I think I've learnt so many new terms, new ideas, and I feel like I've absorbed even just a tiny little bit of your passion tonight. So I may just stay up and program all night. I can't back that up. But right now I want to.
I'll order the pizza and Coke for you.
Sweet,
And the
thank
Coke.
you. And I think even if students from participating in the challenge just get a little bit of that enthusiasm, have those wins with those tough programs, what a great adventure and what a wonderful way to develop their computational thinking as well. I think we've touched on so many elements and related tangents this evening that we really truly could have gone on for 8 hours, but we'll have to block that in for another time. Absolutely. Now, we have another ACCELN broadcast with our details still to be finalised. We'll get them through in the next couple of days or 5-6 days. And if you want to join our ACCE learning community on Google+, you can get more details and ideas, not just on computational thinking, but you'll become part of a community that shares lots of great ideas as well. And we also invite you directly to watch our Hangouts from that community. If you have any further ideas on shows we can run, or you'd like to join our panel in the future, please let us know.
Thanks,
And
Amanda.
remember, you can view all of our past Hangout recordings at acceln.wikispaces.com. Thanks so much for joining us.
Thanks, everybody. And we look
Bye,
forward to
Nikki.
seeing you then.
Bye.
Bye, all.
Bye, everyone.
Good night.
Bye.
Bye.
Bye.